Section 4.6, rectilinear motion. Here we're going to be looking at motion that goes back and forth along a straight line. Like let's say a particle going back and forth like this. Could be going straight up and down. It could be going at an angle like this, but it's going back and forth along the line. It's not curving around and so forth, okay? All right, so rectilinear motion. Let's take an example here. And let's assume this is a straight line, by the way. All right, here's 0, here's 1, here's 2, here's 3, -1, -2, and -3, okay? Let's suppose we have a particle travel along this axis right here, okay? And let's suppose the particle starts at 0, okay? I don't know, maybe this is 1 foot, maybe that's 2 feet, maybe it's 1 meter, maybe it's 2 meters, or whatever, okay? But anyway, let's suppose that the particle starts at position 0 on this number line. It's actually going along this number line. It's just I want to draw it go back and forth and you won't be able to see it. So I'm just putting it along the bottom part here, okay? Then after 1 second, your particle's at position 2. So 2 feet or 2 meters, whatever the measurement's in, okay? So this will be 1 second. So your particle did like this, okay? Travel along the line. Now what happened after that is your particle turned around and started going, or your particle turns around and starts going the other way, okay? So I'm going to put, it does something like this. Now keep in mind, the particle doesn't actually turn like that and go like that. It's really just going along a straight line. It's hard to see it if I draw it all in one line. All right, so after 2 seconds, your particle's at 1, position 1. All right, then after 3 seconds, your particle is at position 0. And then after 4 seconds, your particle is at position -3. So here is 4 seconds. So you can tell it kind of speeded up quite a bit whenever it went from 3 to 4 because it covered like 1, 2, 3 feet basically, okay? All right, let's suppose I want to do a position versus time graph of how this particle traveled along this axis. So what I could do is I could set me up a coordinate plane here. I could say, okay, that's the t-axis, and t is in seconds, okay? And this is my position. I'm going to call it S of t here. And maybe I have 1, 2, 3 right here, and I have -1, -2, -3 there. All right, so maybe this 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, and so forth. Okay, maybe I'll put a 5 right here. All right, so where's your particle at 0 seconds? At 0 seconds, your particle is at 0. So at 0 seconds, my particle is going to be at 0. How about at 1 second? 1 second, my particle is at 2 or 2 feet, whatever you want to call it. So after 1 second, my particle's up here at 2. Then what happens? At another second, or at 2 seconds, my particle's back at 1. So at 2 seconds, my particle's at 1 right here. So my particle might be doing something like this so far, okay? All right, and at 3 seconds, my particle's back at 0. 3 seconds, the position of particles at 0. Let me get the marker to right here. All right, then at 4 seconds, it speeds up and my particle goes to -3. So at 4 seconds, my particle's at -3. And it does something like that. Or it might do something like that, okay? All right, so what is this? This is a position versus time curve for this particle that's just moving back and forth along the number line here. Now, what does this part represent? The part of my graph that's above this t-axis right here. That means that my particle's on the positive side, or it's on the right of 0, right? And then what about this part down here? That means that my particle is what? To the left of 0, right? Because that's what, after 3 seconds that happens. All right, what does it mean that whenever my position graph here is increasing? It means my particle is going in a positive direction. Then what happens here after 1 second here? It turns back down and goes what? Downward or decreasing. And what happens after 1 second? My graph goes what? Back towards the negative direction. Okay, keep all that stuff in mind. All right, let's look at velocity and speed next. Velocity and speed. What's basically the difference there? Velocity gives you the speed with a direction, where speed just says maybe the car is going 55 miles an hour. Okay, where velocity would say it's going 55 miles per hour north, 32 degrees west or something, okay? All right, so let's look at this. If a particle in rectilinear motion has position function s of t, then we define its velocity function v of t to be, okay? So s of t is the position function of the particle. We say that the velocity v of t is equal to the first derivative of position. Okay? And then your book goes on to say that speed tells us how fast the particle is moving, velocity tells us how fast in a direction, like we just talked about. Then it says speed, they define as the absolute value of velocity, okay? Then it goes on to talk about acceleration. And your book says this: define the acceleration function, which you're going to call a of t. They say take the first derivative of velocity. All right, so let's put this all together here, okay? And write it nice and neat. Let's suppose I have a position function s of t, okay? And I want to find its velocity. I want to find a velocity function. I'm going to call that v of t, and I'll find that by taking the first derivative of position. My acceleration, I'm going to call a of t, and I'll say, okay, that's equal to the derivative of my velocity, or I could say it's the second derivative of my position, right? If velocity is the first derivative, I could say acceleration is the second derivative of my position function. Then your book goes on to say, or your notes you could say, a particle in rectilinear motion is speeding up when it's a velocity and acceleration of the same sign, and slowing down when they have opposite sides. Okay, let's look at that for a second. A particle in rectilinear motion is speeding up when its velocity and acceleration of the same sign. Let's suppose I have a position versus time graph here, okay? And we look at this curve here. When you say that looks like if a particle in rectilinear motion is following this, wouldn't you say it looks like it's speeding up? Speed's increasing? I would say that. Let's look at my velocity function, and let's look at my acceleration function. What is the velocity if I'm given a position here? Suppose this is s, or we could even call it s of t, okay? What is my velocity? First derivative of position. So look at the derivative. Look at the slopes of the tangent line of this curve. Well, they're positive, aren't they? So if my velocity is the first derivative, then the first derivative or the slopes of the tangent line are positive, my velocity is positive here. What about my acceleration? My acceleration is the second derivative of position. What did we look at when we looked at second derivative a couple of sections ago? We looked at the concavity, right? Is this concave up or concave down? Concave up, so that means my second derivative must be what? Positive. Velocity acceleration of the same sign, isn't it speeding up? Yeah. How about something like this. Suppose that's my position versus time. And this is my function, I guess you could say S of t, okay? Look at your velocity. Look at your acceleration. In particular, look at the signs of each one of them. What's the sign of your velocity function? Well, velocity is the first derivative of position. What are my slopes of my tangent line? Positive or negative? They're positive, so my velocity is positive. How about my acceleration? My acceleration is the second derivative of position. Second derivative measures concavity, right? What is my concavity here? Downward. So I'd say my second derivative is negative. Velocity and acceleration have opposite sides, so this particle must be slowing down. And you would see that, right? Because it looks like it's increasing very quickly at first. And then what? Kind of tapers off and slows down. So what are we seeing? Velocity, acceleration when they have the same sign. Particle speeding up. When they have opposite signs, particle is slowing down. Keep that in mind.